Hello, everyone. I'm Ashutosh Dhekne. I'm an assistant professor in the College of Computing, School of Computer Science, and I'm going to talk today on tiny data, trying to do more with less. In general, if you think about sustainability, there are three pillars that we are talking about. The first is planet, the second is people, and the third is profits. This goes by many different names. There could be environment, ethics, and economics, and so on and so forth. But basically, there are these three aspects of sustainability. When we think about big data, we are essentially saying we are going to capture a huge amount of information or data from our environment and then take a little bit of it and process and perform inferences or do something useful, right? In contrast with this idea is the idea of tiny data. The idea that you can only take the little bit of data that you need in the very beginning, only transport that amount of data, and only process that little bit of data to actually perform inferences and to actually have or to make something good, right? Now, this thought or this thought process means that you should not even be collecting too much of data. And one of the primary sources of large amounts of data that is being collected today is cameras. And I will take a very simple example in the field of education. Think about, so I teach networking, I teach mobile computing in the fall and networking in the spring. Each one of my lectures is recorded. Each one of my lectures is also live streamed. The amount of data that I'm actually producing per lecture, per 1 hour, 15 minutes of my lecture is somewhere close to 700 MBs to 1 GB, right? In contrast, if I am an elementary school teacher and I write on the board a lot, right, then all that is really needed for the students is what I wrote on the board and what were my hands doing while doing so, right? How was I moving around and so on. That's all that is really needed, but we capture all of this using cameras and create a very wasteful stream of data. Instead, part of our research focuses on trying to localize the pen on the whiteboard and trying to localize or trying to understand the actions of the teacher by actually putting sensors on the body of the teacher. This allows us to capture just 1 MB of data for 1 hour of a lecture, and then that can be transmitted over the network. It can be stored very easily. It can even be transmitted over FM radio, which is a project that we are looking forward to, and then can be captured by student devices, either in the classroom, online, or really far away, through FM radio, for example, and then drawn on the screen, right? This allows, for example, to have about 700 hours worth of teaching or lectures in the same amount of disk space that would be required, for example, in Khan Academy videos for just 1 hour of video. Okay? Which means now you can reach a larger audience. The amount of bandwidth required, the amount of internet coverage required is much less. You can also store that data for a significantly lower cost, improving profits and enabling even startups to get into this space. The idea can be extended to many, many functions and many, many things that we do in daily life. A simple other example is where autonomous vehicles find it very difficult to follow guidance given by police personnel or law enforcement personnel on the road, because that's not an event that happens every day. So autonomous vehicles don't understand that, well, we have to pay attention to this one particular police officer who is going to give some directions for traffic to follow. Instead of using cameras to actually detect all of that, if the police officer was wearing a few sensors on body, and then that information was directly conveyed to the autonomous vehicle, we are talking about just few KBs worth of data that could actually direct a vehicle in the right manner, right? Similarly, there is the lane detection problem for autonomous vehicles, where vehicles are currently using camera systems, LiDAR, and so on, just to determine which lane they are on, because GPS cannot help you there. Instead of that, instead of using camera systems, if we install just a few sensors at the crucial points where cars need to make decisions of exit, etc., Then, by using again a few KBs of data, which is broadcasted, so that all cars can benefit from it automatically, we can actually direct cars, autonomous or manual driven, to the correct exit at the right time. Which means Google Maps could then give you guidance about, well, move to the rightmost lane now to actually get out of that exit 2 miles later because there's going to be traffic. Right? Information like this, which has to be deduced through a lot of compute and a lot of transport of data back and forth from the cloud, can actually be avoided if we start to think about most of our problems in the tiny data format, right? So by doing that, we can actually benefit the planet because less amount of data gets produced, transported, so less energy is needed to store, transport data, and to process data. It is easier for small startups to do so, and therefore allows us to democratize the data part of computing. And it also allows social benefits because since data can be broadcasted very easily when it is small and tiny, everybody benefits equally. Right? Thanks so much. I will save 30 seconds of time and recoup some amount of time.